Okay, is it any better now? Because I see... Because I see again upload rate is back up. Okay. I'm using my mobile internet because it's faster than my own. So it's not as stable, but it's fast. Alright. So strategy compared to command defines how stuff is done. So we can have multiple strategies of how to do the same thing. And the best example would be some algorithm, for example, sorting algorithm. So we can have different ways how we sort elements. So we pass in a collection of elements, and within the interface we can define that we sort elements as long as our collection consists of comparable elements, and different sort will be implemented that way. And then we can inject an algorithm for sorting without the need of, let's say, hard coding logic or doing a switch statement. It is much more natural and fluent with the object-oriented design. Factory is another design pattern which solves a very simple problem. How do we create complex objects? Factory creates objects of the same type, unless it's a generic factory. So there should be some base, either a parent class or an interface. And based on some criteria, usually a single value, you can determine what kind of object you want. The argument that we pass the factory, how we create objects, should be as simple as possible, because the whole thing that the whole problem that factory solves is having complex many objects. So we want we want to have a unified way of creating different complex objects, but in a simple way, in a unified way. And that's why factory. So here is an example of car factory. Maybe it should have been car parts factory rather than car factory. Maybe it's car factory should return different cars. Maybe Mercedes and a different version of Mercedes, like I really don't know Mercedes brands. I mean the names of cars for Mercedes, but let's say you return Mercedes car and a different version of it, a different model for it. Abstract factory is very similar to a factory, but when you talk about abstract factory, it means that you create a factory to create factories. A traditional standard classical example that you would find on Wikipedia as well is operating system and virtual machine. Virtual machine creates operating systems. An operating system has all sorts of UI elements. So virtual machine is like an abstract factory. It's an abstract factory because it creates other factories. Operating system is like a factory for GUI elements. So you have a virtual machine which creates operating systems, which creates buttons, menus, and stuff like that. So all those objects are UI elements and they can be rendered. So what problem does it solve? You can create a button in Mac OS and in Windows and in Linux, but it will be done differently. It will look differently. So when you create a different factory for it, you will have a different implementation for creating the same button or menu, and so on. Is factory pattern used in game development often? I see class names with factory in them. Yes, it's very, very commonly used in game development. Factory pattern is great for creating enemy entities, complex or not so complex game objects around the scene. It's really nice, and I used it myself when I was a game dev a lot too. For instantiating scene objects, decorations, it was good. So here you can see an example, not an OS, but car manufacturers, car parts manufacturers example. So imagine that you have some big car parts retailer, manufacturer, and it has a monopoly of other car manufacturers, other brands like BMW and Mercedes. So BMW and Mercedes can both create parts, car parts. So when you create a car part, so car parts manufacturer can create a factory which creates car parts. And then we have all sorts of car parts, and you can see how complex the hierarchy is for car parts. Rear window, rim, door, wheel, body, rear mirror, front mirror. So you have all sorts of different objects, and it might be quite complex to create each. You might pass a lot of parameters, but you have some pre-made template for creating objects, and Factory does just that. Prototype is basically cloning objects. Instead of trying to calculate and determine state when we want to copy an object, when we want to maybe reuse an object but don't touch an existing one, we need to clone it. For example, when you have one list and you say that you want another list which is exactly the same, except that it has a few more elements to it, but you also want to keep the previous list untouched. So then you would have to clone the first one and then add stuff to the second one. Extra stuff. Cloning means that you don't need to say some property equals to another property, but it means that you just say clone and it returns you a full instance with all the copies that you need. So there are two kinds of clones, shallow and deep. Shallow clone means that it points to the reference that is not a new reference, that is cloning only the primitives, only the immediate friends, only the members closest to the class, to the original class. So if I have a person and a person has a name, age, and weight, and I say clone, those will be copied. That's fine. But if a person has a parent and a parent is another person, after cloning a person, it will still point to the same parent. The parent itself will not be cloned. So deep cloning would mean that I create a new parent and call clone from the parent. So deep cloning means that I recursively clone all that can be cloned from within whatever is being cloned. So deep cloning will point to all the new references so that when you change something that has been nested within some object, you will change it as you should. like you won't affect whatever you cloned. You will have a whole new state. RTS is a good example of cloning. You have lots of duplicate objects. Basically, so many objects that are the same, except position is different, rotation is different, color is different. Maybe has slightly more things within it, but they're clones essentially. Lots of thousands of clones. And sometimes we compute the state of an object. We don't have to compute the state of an object. We can clone it. So it makes our lives easier using the prototype design pattern for it. In C#, we have member-wise clone. Member-wise clone is what clones makes a shallow copy of an object. So we need to call it from every reference type that we have within the object. Cache is basically what browser uses on daily basis. So you basically have a high latency to fetch something from the web, and to avoid suffering from high latency every time you let's say open an image, you can cache it instead and have some logic which determines whether you should use whatever you cached, which means whatever you stored somewhere, or instead you should re-fetch it from the web. So by having a logic which determines what is good enough and trustworthy enough time for getting something, like do you need to get from a store or do you need to get from the web, that's what cache solves. So image cache, where you have an image that needs to be rendered, which you got from, let's say, Google search. You will have it in a local store of your browser in its cache. And I'm not sure what needs to be done. I think if I reload the page, it will not refetch all the images or the one that you loaded. It will keep it in the cache and simply return it from the cache. It will load it again if, let's say, 10 minutes passed after it was fetched. Each client has its own algorithms how caching is implemented, and that's fine. Last design pattern that I want to talk about is object pool. So with object pool, you have many objects with short life cycles. So creating an object is expensive. Destroying an object is expensive. So let's say if you have a particle system, like here, it will be quite complex to... it would be quite performance heavy to create and destroy hundreds of thousands of objects, because that's how many particles a complex particle system has during its lifetime. So instead of creating hundreds of thousands of objects, we can create a certain amount of objects that are visible at a time. And instead of creating and destroying, we enable and disable after a certain amount has been created. So we don't destroy objects, we store them instead. We keep them inside our object pool and we get instead of create. So it's a bit similar to the cache, except that we have hundreds of thousands of objects that we don't need, that we don't want to create, that we just want to use and we can reuse. So object pooling involves a cycle which is like, I create an object, I first check if I need to create or get, and checking involves checking how many objects are already creating. So I create or get, then I after the last object was used, I disable it and reset its state and put it to the objects pool store. And the moment I will need it again at some point, when it will be fetched from the cache, well, it will be simply enabled and not created. And that's a quite efficient way of working with hundreds of thousands of objects which have short lifetimes. So that's that. Now, what pattern would you like me to implement? What do you think? Do you have a preference? Clones, command pattern, object, pooling, those are three most interesting to me. Okay. Right. So I'll call this design patterns lesson 1. And that's good. Create. Let me create a project. So we'll start from a clone. So we need to think of a problem that we could solve. Why did I name it with spaces? I have no idea. That's okay. Okay. And I will create a console app as well. Oh, wait, it is a console app, right? Yes. Okay. I'll create another project which just calls it .NET Core. Design patterns, lesson 1, core. I'll call it logic. I'll call it design patterns lesson 1 dot implementation dot well, core is good enough, I guess. And here I shall rename it a bit as well. Presentation. And change the assembly names as well. All right. So the first one that we will try to do is the prototype. So what problem could we solve? What problem could we solve? One problem that comes in mind is having a complex entity. So creating a clonable thing involves two things. We want to have a way of cloning pretty much anything. Just have a tag which tells if something can be cloned or not. And let's say if we want to clone animals or people or furniture, we can do it in a unified way. That's the way to think about it when making a design in object-oriented programming. You want to have a unified way of doing it. So iClonable will be an interface, and this will be an interesting interface because it will be with a very nice constraint. And look at this constraint. This will be interface where t, and this right there is beautiful. Does anyone understand or could explain why I chose to write something like this? And is there anyone who could name what I wrote here? What is it called? Isn't that generics? It is generics, but it has a special name. This is called F-bound polymorphism. You constrain your generic with your own type. Like, this is a generic interface, and you constrain this generic interface with itself. So what does it mean? It means that this interface has something that returns its own type. I don't know if this works in Java, but at least I don't know if Java has such generics actually, but I know that Java has ways of cloning as well. Now the actual cloning will look like this. So we have a person, which is iClonable. And we say that it's person. Now we need to implement it. Like I didn't mention, but in C# we have member-wise clone. I think shallow copy of the current object. So we don't need this. So our copy is this, and we need to define some properties. So I'll just say public string name, public int, public date, time, age, birthday. You don't change those, so that's why no setter. Public float weight, you do change those, so set get. Public float height, set get. And let's create a constructor with those. I really hate that constructor is at the top. Right, so we have clone, and we cloned our object. That's it. That's all clone is. Right, so this returns an object, so you have to cast it. It's safe to cast it this way because member-wise clone will return its own clone. So I know that this, what we are calling it on, will always be a person. So casting it like this is safe for this one. I also could have done some TDD, but simple tests will be enough. I prefer writing tests. I'll show that writing tests is not difficult. Oh, nice! It has templates. I'll use XUnit for testing, of course. So I'll call it design patterns lesson1.core. dot tests. Right? So this is a person, not class 1. And let's say a person has a parent. Public person parent. Parents don't change, right? So actually there might be 2 or more parents. So you always have 2. So let's say mother and father. And we will test something interesting now. Right. So that's 1, and this is someone who has a parent and father. Right. Mother is mother. And father is father. Next, we say that we don't do anything. I want to demonstrate the difference between shallow and deep copy. So I'll go to here, and I'll say I'll say prototyping tests. And here I'll say clone person, okay. Clone person shallow, okay. So we're testing if cloning a shallow person works. So I think a theory would be okay here, and inline data we can create a bunch of people. So var people var person. Hello, jumbled words. Var person is new person. I did not reference the project, so I shall. The one that I test. And here is the person public. It's not public. It's public, but this is not public. So I won't be able to access this interface from the outside. Okay. Let's close all but this and the person, the only 2 that are relative to me at the moment. So when I create a person, why doesn't it give me autocomplete? Because I'm not using person. So name, Thomas. Birthday, actually I passed those from parameters. So name, date, time, name, birthday. What else? Weight and height. Float weight, float height. So for the sake of clarity, let's have an equals override. if object is not I think I could do pattern matching, but I don't remember syntax. I'll do it like this: var person, var other is object as person, and then I say if other is null, return false because they're of different types, and else return. Now we compare name, other name, and oh, come on. What kind of English keyboard do I have? Okay. And wait. Why no overloading operator? Because that is, I think, the same as well. I mean, if I have equals override, it will work too. No? Yeah, I think so. We can try. So this is just for the sake of... Okay. Of... having a way to compare if we really cloned it properly. So name, other name, weight, other weight, height, other height, name, weight, height, birthday. And person, father. Or maybe not. Maybe not. How do I override those? Operator. Public override bool operator. I'll Google. Operator overriding C#. Haven't done this in a while. Public static box operator plus. Public static person operator equals and no input. Person. So we say, we don't say. Me dot name to parse. What do you mean to parse? Oh, I meant parameters, but you got it. Arguments, yeah. Overall overloadable operators equals equality operator overloading. What am I missing? Oh, to also be defined not equals. True, bull. But that's besides the point. I also need this one. Yeah, so weird. Okay. So this one is very simple. Just change to this. Oh crap. Father, if actually I'm stupid. I can reuse it. The overloaded equality operators should call the override equal methods, by the way. Yeah, makes sense, and I'm about to refactor that. Father. Other father and mother, other mother. It's not really difficult, and it would certainly work either way. So this one we'll put in equals override. And we will check the type. So var other is object as person, and if object is null, we return false, else we return this. So we got this one, and here we return, I think what you meant is me equals other. Very simple. And here we say the opposite. Fair enough, I guess. What's wrong? Return. Okay. So we overloaded the operators, overridden operators, and now we can test a few things. We need to test, of course, first if our comparison works. So I'll make one more test for comparison test suite. While go back fast. Yeah, I think it works. Okay. So, wait a minute. What happens if person is null? So if I pass here and null. as father. Father equals other father. Yeah, null and null equals null. Okay, that should work too. So let's try it out. Let's try to pass multiple things and see how it works. Make test public, because otherwise it won't be discovered. Theory, inline data. And we call it compare person no parent. Okay. And we pass in Thomas, new date time. Yeah, new date time. 2000, let's say 0505. Like this. Birthday. So we have name, birthday, weight, and height. Weight 50, height 160. And what else? That's all. No parents, I said. String to long. Parse. I cannot pass something like this. Well, I can pass something that is now. I cannot as well, of course. No, it's not that. It needs to be a constant here in inline data. So it is a bit tricky. I'll say it's class data type of and I'll move those to class. Though I really dislike it now. Though, do we need to compare all sorts of different things? I guess facts will be enough. Just because it's not the topic of this lesson, I guess. No need input. Okay. Person 2. Let's see if they work. And person 1, person 2. And I check if they are equal to one another. So I expect, oh, I can check equal like this, of course, because it does the same. Okay. Now if I hit test, run all tests, it should succeed. This will fail, of course, because it's a fact. And this is a fact as well. This is fine. I don't need this. And I won't need that. Run all, please. And failed. Or did it? So it says of course it failed. I know why it failed. Does anyone know why it failed? This is a problem. Less than I will need some static class to add comparison of those numbers, because we cannot compare floats just like that. So I'll call it numbers comparer. Yeah, static is the way to go. Public static, and let's say bool are equal float, or like this. T, can I constrain with a number somehow? Numbers comparer, that's my own. Count int. I guess I don't know. For now, floats are enough, and I won't overkill it. So we have two numbers. And I say that they're equal if their difference apps if the difference is less than tolerance. Tolerance 0.0001. That's good enough for me. If difference is less than tolerance, I'm good. F. So we go here and here I'll say numbers comparer dot numberers are equal weight and other weight, like this. Oops, sorry about that. What's wrong? It cannot be applied. Float and bool. I'm sorry, guys. Wait. Oh, okay. Cool, and Oh, I didn't refactor this one. Right, like this. Okay. And if we run it now, I don't check height. Are you sure? I do check height. Oh. So it's not equal. Why is it still not equal? Oh crap. I thought... Yeah, they're null, but they are null. I mean, this is null and this is null, so null is null. So it should be good. Wait, height, name. Isn't null not equal to null? Really? Never checked that. I mean, what do you mean then? I'm confused. Mm-hmm. Well, as stupid as it sounds, we can test. All good for sure. So that one doesn't fail for sure. This one is correct. This one is correct. Names, they're also correct. Now, what about dates? About dates, I don't know. I don't know how dates are compared. The last thing that might be tricky. Hello, Joshmond. Yes, they are, but don't they have the comparison out of the box for dates? Date one, date time. And I'll say, what did I pass here? Oh my god, okay. Never mind. I'm pretty sure that's default, we'll see. B-Day is... Right now it was daytime now in both cases, and it changes a bit, slightly. So that's why it was giving bad answer. But now I'll put something like 2000, 0505. Okay. B-Day, B-Day. Mm-hmm. Now it should be fine. Okay. Me equals other. If me equals null and yeah, if me is null, if me is not null, then I do this, else I do this. I think. Could I make this more simple? Could I make this more simple? I don't think so. This doesn't look nice. Though, what could I do better? Don't know. Cannot figure it out. Anyways. Did I just create infinite loop? No, of course not. Okay. Mother, father, null, null. Okay. Good. Where? If me I think this I think I messed up majorly with this one. Because this is comparing itself and it's recursively calling itself and it is infinite, I think. Me, person, other.